In this first lesson, we'll spend the first hour talking about substituting values into formulas. I don't think that'll take us the full hour, so we'll switch over to the middle section, which is solving formulas or rearranging equations and formulas. The middle one requires probably the most amount of effort in terms of writing. Once we get through those two sections, I think that will be sufficient for today's lesson. There's not that many questions, but also I don't intend to rush through them as per usual. Nice and slow. So let's take a look at the first topic here, which is substituting values into formulas. It's very common in construction to encounter formulas where sometimes it's not so much about the development of the formula, you're just worried about how you're going to put the information in there. Things like units would be important. So you've seen that kind of situation a lot in the course regarding surface area and volumes, especially areas and perimeters as well. But when you start dealing with formulas that come from physics and other disciplines that are a bit more complicated and less natural for you to visualize the formula because perhaps you don't have the background in physics, then you got to be very diligent and just organized when you're dealing with these formulas. So in these first couple of pages here, page 2 and 3, you can see that the author is going through questions and just plugging in numbers into formulas. There is discussion about units, and there is discussion about other important aspects like estimating the solution. Now, I'll try to touch on those things as they are relevant to the examples that we'll cover. The examples that we are covering are available on page 4. And here you'll see examples that span just some basic algebra and a little bit of physics, some surface area and volume, some nonlinear equations to word here as well. And then there's a question down here involving a formula from statics. Number 7, I'll try to cover it in class, but I don't want to be talking about this formula, not because of anything else. You might see it in other courses, and I don't want it to take away from the other courses. So that's pretty much it. So I've chosen the ones here in blue, just a few questions. If we find that we go through these really fast, then I'll step back and we'll do some more calculations. We might do 4 and 5 as well. Question 7, I'm not saying that I'm skipping it, then it's going to be on your test or something. That's not my objective. I've already created your assignment for next week, and I don't include this question in it. So that's all. I'll just say that don't worry about question 7. But anyway, I just don't want it to turn into a physics lesson. I just want to stick to developing those skills for you that you need to succeed in the next course as well, and in the program. So here's the first example. I'll just zoom in here carefully. We have y equals this rational function, and we're just asked to find y when x equals 2. When it comes to formulas and substituting quantities into them, the way that I've been very successful at doing this without too much risk is writing the following down. I always write a template. So if I'm going to plug in numbers for x here, then I'm gonna replace all the x's with brackets, and then later in those brackets I'll just populate them with whatever number we're told. So for example, here it says x equals 2, so I'll just put 2 there. And at that point, it's an arithmetic question, and I'm confident that you can process this type of thing well. So when anybody's ready, just let me know what the answer is in the chat. Leave it as an exact answer, just as a fraction if necessary. Let's not use our calculators today, as much as possible. Try to avoid the calculator today. Does anybody have a value for that? What's the numerator? It's very quiet today. There we go. Thank you, guys. And the denominator, of course, is 3. There's no need to. Thank you. There's no need to process this. I'm relying on your participation on this one. Otherwise, I don't want it to be like a one-sided conversation. So thank you for that. So anyway, there's your first question. Y equals 8 over 3. You could write it like that. You could also write it like this. It just whatever you feel like. I'm not going to be too strict. We're not solving for a variable in this case. The variable is already isolated for us. So you can be a little bit lazy in terms of how you write that. In this next question, we have a very famous formula, which is the conversion from Celsius to Fahrenheit. For anybody in the class that's lived in the States, for example, they're probably used to having to do this conversion now back in Canada or vice versa. The main thing with Celsius and Fahrenheit is this factor of 9 over 5 or 1.8. If you can actually train yourself to convert from Celsius to Fahrenheit, it's actually not that hard. But I'll kind of walk you through how I would do this just on paper, but also in my head. I can train you how to do Celsius to Fahrenheit in your head. It's actually pretty cool. So here's the formula. Fahrenheit temperature is 9 over 5 times Celsius temperature plus 32. In this case, the Celsius temperature is not sustainable for human life, but so this would not be the temperature outside at some point, unless you're on Venus or something, or whatever planet that would be that has that temperature, maybe Mercury or something. Anyway, so what the heck is this going to be? Well, if you want to do this in your head, I'm talking about doing this in your head right now. Take 220 and divide it by 5. I would divide by 5 first. That would be 44. And then 9 times 44. If you can do 9 times 44, you're in the clear. So that'd be 9 times 44 would be 360 and 36. So that's 396. And then add 32 to that, 398, 428. Can someone confirm? Is it 428? If anybody have 428 as well? Awesome, thank you. If you want to do this in your head, divide by 5 first. Because that's all you do with Celsius to Fahrenheit. Let's try another one. Let's just try another one just for that practice, because it's pretty cool. So let's say that it was, let's say that outside right now, I don't know what the temperature is, like, I think it's 5 degrees Celsius outside, okay? I just was checking the weather channel. It said 5 degrees Celsius or something like that. If we had 5 degrees Celsius, let's see if we can do the calculation for Fahrenheit. Guys, in your head, okay? Don't write this down. I mean, write it down at the end, but just try to do this in your head. So you see here, 5 divided by 5 is 1. 1 times 9 is 9, and 9 plus 32 is 41. Anytime you have a Celsius temperature that's a multiple of 5, you can go to Fahrenheit quite easily because dividing by 5 on a multiple of 5, of course, will give you a whole number, and then you can multiply that by 9. And you should know your nine times tables fairly good because you've been using them for a long time. Anyway, hopefully that question was interesting and you learned a little bit about conversion of temperature. Here's the next question. It says here, given 4pz equals this equation as follows. Solve for p when you know that q equals 2 and z equals 3. I'll retype the equation. I know that it's a little bit blurry here on my Zoom. So let's just type this again. 4pz equals pq squared. pq cubed, sorry. It's qz squared. And we're trying to plug in q equals 2 and z equals 3. So the first thing that I would do here, as I did in the first example, is replace all of the q's and z's with brackets. So there's a bracket, and then a few more brackets here, and I think we're good. Notice how the only variable that survives is p, because that's what you're solving for. So anywhere there was a q, we're going to put a 2. So there's a 2 there, there's a 2 there. Anywhere there's a z, you're going to put a 3. So there's a 3 there and a 3 there. Can someone confirm that they agree with this statement here? Who agrees with this statement? Thank you. Thanks, guys. Okay, so now it's a matter of just polishing up our algebra, or our arithmetic, sorry, and a little bit of algebra. So 12p equals 2 to the 3 is 8, so that's 8p. And then this one here, you're going to do 9. Remember, exponents first. 9 times 2 is 18. Move over the 8p, and then divide by 4. You can do this as a decimal if you like, that's fine. Anybody else get 4.5? Awesome. Thanks, Nicholas, Sheldon, Marco, Cameron, Nikolaos, Bartek. Did I miss anybody? Hopefully not. Cameron. I gotta, it's kind of like we're on one of those like shows where I have to thank all the guests. Because you are guests today. You are guests, but also you are active participants. Okay. So I'm gonna do a few more of these. We definitely have time to do that. So I'm just gonna transcribe the questions into the chat here, into the workspace. So we're gonna do question 2, page 4, question 2. That's y equals x cubed over 1 plus x. If you don't have the sheet in front of you, you can just copy it off of this, okay? And I'll just say that we're told that x equals 4.65. So that's what we're working with here. Probably we're going to use a calculator here, because 4.65 cubed is not looking very fun to do by hand. Anywhere there's an x, you're going to put brackets. That was my advice, and I'm going to stick to my advice. Anywhere there's a bracket, you're going to put this number. So there you go. Yeah, this is calculator work, everybody. I'm not gonna, this is probably one of the few questions where we'll have to whip out a calculator. So I'll go grab my calculator as well. We need 3 significant digits in our answer, so put extra digits in the question. 100.545. And the bottom's easy. The bottom's easy. No need for any work there. The question somewhere says 3 significant digits, so just divide that by 5.65. And your final answer will be 17.8. Awesome. Thanks, Nicholas. Let's line them up like that. I think it looks cool. Easier to read. So that was question 2. We can also do 4 and 5. I'll do 5 next, and then 4 is like I think 4 is a surface area or something like that question. I'm just looking on the side here. Yeah, it's a surface area question. So we're going to do question 5 right now. And question 5 says, I'll just retype this. So this is what the question says. Oh, it's all good, Norris. Thank you. Don't worry. We're doing some what hopefully people will think of as light work today in terms of the start. We're just practicing using formulas here. So there's the question. It's solve for y given that x equals 3. I've just rephrased the question a little bit more compact. Oh, that's okay, Matthew. You are just fine, my friend. Don't worry. We haven't done too much. So in this case, what you want to do is replace all the x's with brackets and put 3 in those brackets. So x bracket x cubed. Oh, sorry, we're replacing the y's. My apologies. We're replacing the x with brackets. That's my bad. So x, and then another x is here. So we have that. Anywhere there's an x, we're going to put a 3. So we have here 3y. Now 3 to the 3 is 27. And then plus y. Collect all the y's onto one side. And divide by 2, 13 and a half. Some students ask me, confirm, thank you. I appreciate that, Nicholas. Thank you. Some students ask me when I'm writing these equations down, like how am I getting all these, like typing them in without too many like confusion or effort on my side. I'm just kind of doing it using the equation editor. So if you want to know how to do what I'm doing here, some people had asked me this in the past. You can I'm in PowerPoint, but you can do this in Word as well. Just put a box. Here's some letters just to fill in the space. Anyway, you would go here, insert, insert here, and then it's insert equation. Okay, so if you do that, this lecture is being recorded, so you can look for this later. So you do insert equation, and then all the rules for the equations are here. I had some students ask me that even this year, so that's why I just wanted to put that out there. If you can master typing equations, it is slow in Word, and some things about Word that bothered me like that. I actually use a different program to do all my math. So if you're interested in the program I use, perhaps I can show you that later on in the lecture today. Obviously, I'm not going to record it because it's going to have like I won't record it because it has like information from other courses, and I don't know if that's really something I want to put in a public domain. But in this case, the language that I use is called LaTeX or LaTeX, and it's free. Okay, it's free. It's on all systems, so pretty much any OS, as far as I know, and it's open source. So meaning that it's always being fixed. Okay, so if you have Windows, Mac, or Linux, even for example, then you can use this programming. It's like you're writing a web page, but in the beginning, it's really stressful because it's like it looks like it's all computer programming. But when you master how to use it, it's incredible how good it is. And then I'll show you some of the stuff that I've done with it. Perhaps I can do that after we finish the lesson today. Okay, so we'll do question 4, and then after that, we'll skip over into the next section. One thing I get frustrated with using Word or PowerPoint in terms of writing math and just generally the documents is that the file sizes get very large. Have you noticed that the file sizes get really large when you're doing projects? Or is it just me? You're like you have I don't know if you monitor your file sizes, but anyway, you will notice if you check the file sizes, you start to see that they're like 10, 20 megabytes each, which sounds like nothing, but if you do a, 400 or 500 documents at 20 megabytes each, you're starting to get into some serious gigs there. Okay, so question 4. Question 4, we're given the following. We're given the radius is 0.50 meters, and we're given a height of 1.2 meters. The font is very small, So if I make a mistake here, please correct me because I'm just reading it off the side tab. So this is just the formula of the surface area of a cylinder. So there's no need to discuss that. But anyway, what we're trying to do is find the surface area of a cylinder. This question here is very natural. The reason is because you've done it so many times. How many times have I asked you to find the surface area or volume of something? In an assignment or a test or in the lecture, I'd imagine it's on the realm of about 20 or 30 times. Correct me if I'm wrong, but I'm pretty sure we've done it like 20 or 30 times throughout the semester. So really, this question here is it should be something very familiar to you. But anyway, it is under the realm of equations and formulas. So I'll just show you how I would input it in this situation. Anywhere there's a variable that I'm going to plug in, I'm going to put a bracket. And then I'm going to copy this in here. You know what? I'm going to copy the units in there too. Maybe the units are a distraction. Let's not do that. Change my mind. I take that back. When I type up your solutions for quizzes, assignments, etc., tests, I like to put the units as much as possible because I want you to see how you can keep track of them as well. That's why. Okay, this is not looking very fun to do, but it is just mechanical in nature. So I'm going to type it on my calculator. You can type it on your calculator as well, and we can compare our answers. So I just read the answer actually. So anybody have an answer for this? Anybody have an answer for this question? That's very good. Thank you, Nicolos. That's the answer key as well. I was just reading it off the side there. 5.34 meters squared. Well done. Cosimo, welcome to the party. Thank you. Okay, so there you have it. We basically covered all the questions that I would have liked for you to do. We can certainly move on to the next topic, which is rearranging formulas. So let's do that. I'll just wait for 30 seconds in case anybody needs to copy anything else here. Okay, so the next section is going to rely heavily on your algebra skills and that you don't get intimidated by looking at a question and seeing all these letters, all these variables. So we're talking about solving formulas. In quote solving, I'm talking about here rearranging or manipulating the equation to isolate something different. I think there's 7 or 8 examples here. We're not going to do these examples. We're going to do the exercises that are companions to these examples. So I encourage you also on your own to try these questions. What I want to do is highlight each of the formulas that are in the examples so that you can see how the difficulty escalates. So here's an example where you're trying to take this equation and rearrange it for r. That seems like you're just going to be moving things to the left and the right. So that would be considered like a very easy question. And we will cover ones, don't worry, we will cover questions shortly. I'm just kind of browsing through these. Here's a volume formula where you want to solve for L. So that would involve some multiplying and or dividing. In the third example, here's a formula where you're solving for R. So that would involve some multiplying or dividing possibly. And the author does a very good job of like manipulating these equations and explaining them. Here's another equation where you're solving for X. Again, using some basic BEDMAS rules. Make sure you go through these examples later. That's why I'm highlighting them. Here's one that is involving deflection of a beam, and you're solving for the force. That's the question that I said earlier, don't worry about in terms of numbers. But in terms of a formula, it's just a formula that you can rearrange. The next question is also the same formula, but you're solving for a different quantity in that formula. And then this last example here is solving for x in this highly nonlinear equation. There's actually two of these types of questions. So this question 7 and question 8. And I think that's about it. So you're starting to see, maybe some of you are seeing these questions and saying, oh my goodness, these formulas are getting pretty weird. I promise you that we will start off very slow with the examples and build up to something nice. So you can see here on this page 10, what I've done is I've sampled like easy questions, and I've basically escalated it to really hard questions. In fact, I try to use as many formulas that look like the examples as possible. So we're gonna do, I have here 8 questions. I think we should do all 8 questions, and then after that we can sample some more questions, and then that'll be it. There's some more exercises as well on the next sub block here. We have 5 more questions, and I just went through some more of them. So anyway, all of the questions we're going to do, they're listed here. So when you're doing a page reference, we're talking about pages 10 and 11 and 12, okay? So just keep in mind we're doing pages 10 to 12, and I'll just write that right now so that you don't lose track of that. Pages 10 to 12. Okay. So here's the first equation. We're asked to solve for b. Let's zoom in here and talk about that. What's your advice on this question? What do you guys think? What could we do with this question? Keep it there. Oh, keep a there. Yeah. You want to get b by itself, right? So just move everything that's not a b. Move everything over that's not a b. Yeah, let's start moving. So the first thing I'm going to do is copy the equation. Now, guys, I'm going to do lots of step here. Oh, that's okay, Marco. That's okay. I figured that's what you meant. So the first thing I'm going to do here, I am going to write extra writing here. So for some of you, you're going to be like, John, you're writing too much stuff. But keep in mind, I'm just trying to make sure that everybody's happy about things. So here we want B. I'm going to highlight B. Let's just highlight B for a second. That's what we're trying to solve for. Oh, nicely done. So what I'm going to do is move everybody over that's not a B. So this A here, this A's got to go. So I'm going to subtract A. But whatever you do to one side, you do to the other side. Also, there's a plus C here. Well, a minus C. We're going to add a C. But whatever you do to one side, you do to the other side. But what happens when you move to the next step? Well, let's take a look here. We've done a lot of adding and subtracting here. These A's cancel. Let's go with a thinner pen. So this A cancels with this A, and this C cancels with this C. So we have exactly the answer, which is what we expect. Nicolas, I think it's plus C. Can you confirm? Thank you, Nicholas. You do not have to write this backwards. This equation is the correct answer. If you want, you can take an extra step and just write it the other way, but you don't have to. You might be wondering, John, why did you put the B over here? Why don't you move the B over? The only reason I didn't move the B over to the left side was because I didn't want it to be negative. That's why. So anyway, that's not nothing too dramatic. Moving things left and right. Okay. So that's that question. With any of these formulas, you have the potential to solve for any of the variables. So this question, D is already isolated, but I could ask you to isolate for A, B, or C, and you could just repeat this kind of process. Here's something cute. You'll like this. So who said they thought it was A? It was just funny. Marco, I'm gonna use you as as an example for a second, okay? So Marco, just work with me for a second on this. Let's say that you by accident you solved for A. What would the answer be? Well, the answer is going to be A equals D minus B plus C. How the heck did I write it that fast? The reason is, when you go to the original question, you see how A and B are kind of exchanged? You can exchange them. Like if you exchange A and B, you still have the same formula. So if you ever have two variables in a formula that you could switch them and you have the same formula, then when you get to the final formula, you could also switch them. So you see the B here and the A here, I could switch them. So I could actually solve for A here and then say, oops, I should have solved for B. And then at the very end, just take A and B and just switch them because their positions are relative. So you see, that's a little bit of a hack. It's a bit of a hack, but you don't have to erase the whole thing. You can use some fun creativity there. Now, in the future questions, anytime that we have a variable that we want to isolate, I'll try to put it on the left, even if you don't literally have to put it on the left. In this question here, the first thing that I would do is write it backwards for that reason. So dv equals m. Now dv, you don't have to put this dot here, but I want to put it just to space them out a little bit, just for this question. In this case, you want to solve for d. Now the thing that's in the way is v. V is multiplying d. So the way that you get rid of something that's multiplying it is you divide. So we're going to divide both sides by v. And whatever you do to one side, you do to the other side. And there you have the answer. The v's cancel, and d equals m over v. So this is the famous formula involving density. What if your question has a fraction to begin with? Well, you still play the same game. Let's write the equation backwards because I want to have e on the left. The thing is that r is in the way. What should I do to both sides of this equation so that I can isolate for e? What should we do to both sides of this equation so that we can isolate for e? How do we do that? Do we add r, subtract r, multiply r, or divide by r? So what is r doing with e right now? E is divided by r. So we want to multiply because you want to do the opposite of divide. So then E is equal to IR. I didn't put the dot in the answer, if you don't mind. It's fine. But anyway, that's that. Forgot to cross out my V's. How is the pace, people? How are you guys doing with the pace? Am I going too fast or too slow? What's going on? Okay. Okay. Cosmo, we'll get you back up to speed here. Which one do you want clarification about? So in the question, you're being asked to solve for D. Yeah, I gotcha. In the question, you're being asked to solve for D. So when you look at this formula here, I just wrote it backwards firstly. This is D here. I want D. The thing that's getting me, that's the reason that D is not isolated is because there's a V here. So you have to ask yourself, what do I have to do to both sides to get rid of the V? In this case, D is being multiplied by V. So I need to divide both sides by V so that the V's would cancel away. And then you would be able to isolate for D. So you're always asking yourself, what is the variable that you want to solve for? What is with it on that side? and you have to think about what operations to do that you have to do to get rid of those other quantities. In this equation, again, I wrote it backwards to start. We want to solve for E, but R is in the way here because R is here. Now, E is being divided by R. So you have to do the opposite of dividing by R to get rid of it. So that's what I'm doing here. I'm multiplying both sides by R so that these R's will cancel. So you always have to ask yourself, what is in the way and how do you get rid of it? So let's approach this next question with that kind of mentality. So we have here, we want to solve for B. Cross it out where? In this example, you're crossing them out right here. Yeah, you do. You cross them out the same way. But the question was divide for the first one and multiply for the second one. The operations were reversed, but they both end up looking the same. True. So in this question here, we're solving for B. So the first thing I want to do is write it backwards. Because I want to have B on the left. So just work with me on that, but I want to have B on the left. We're trying to isolate for B. So that means that the mx is in the way. So how do you get rid of the mx? Well, B is being added to mx, or mx is being added to B. So what I'm going to do is subtract mx from both sides. So if you subtract mx from both sides, that will neutralize the mx here on the left. So then these mx's cancel because they're opposites, and you have the final step, which is B equals y minus mx. Okay. All right, the next question, solving for S. So S appears up here, and it's kind of hidden. It's kind of tucked in there. Whenever you have equations like this, where you have a ratio equals a ratio, or only just fractions on both sides, I would advise you to cross multiply. So how does that apply here? We have PQ over 1 equals RST over ZW. All I did there was I made the PQ over 1, because you can always put something over 1. Here's the cross multiplication step. So we're going to multiply diagonally PQ times ZW and RST times 1. So RST times 1, let me put that in brackets, sorry. So we have here RST times 1 equals PQ times ZW. Those brackets are not necessary. And you'd end up with this. So the first thing you really want to do here is clear out the fractions. Get rid of all the fractions, because now it'll be a little bit clearer what to do in the next step. I'll continue over here on the right. So we have this equation here. We're trying to solve for S. Currently though, I see that we have R and T. R and T are multiplying the S. So we want to do the opposite of multiply. So we're going to divide both sides by RT. Because whatever you do to one side, you do to the other side. And at this point, you cross out the RTs and you essentially have the correct answer. So the RTs will cancel. And then you have the answer here, which is S equals that. Okay. I think it's going to be a break soon, but we still can do maybe one more question. So let's do 17. Let's do question 17, and then what I might do is I might, during the break, I'll transcribe some extra questions and we can practice some more after the break. We'll do more than what I've already initially allocated because we're doing very well for time today. So let's do question 17 now. So question 17 has us solving for B. So let's try that together. Notice that we have a fraction. So the first thing I want to do is what we did in the previous question, which is to cross multiply. So if we cross multiply, we get B minus C times D. I'll put the D in front, it just looks better. And then A times 1. What you want to do now is expand out this bracket. So you're gonna take D and multiply it by B and by C. So you get DB minus DC equals A. Your objective always is to solve for B. So as we're tracking through the question here, we're in a position now where B is well, you start off with a fraction with B on the bottom, which is terrible. Now you're in a position where it's a linear equation, and you can hopefully get something that's easier. So what I'll do is the DC there, I want to get rid of the DC. You want to work from the outside in. So like this D here, I'll do this last. This DC is fairly easy to get rid of because you can just add DC to both sides. So what you have is this now. The questions do look like they vary a lot, but when you actually see the individual steps that I'm using so far, it's always the opposite of addition, subtraction, multiplication, or division. And everything up to this point has been using addition, subtraction, multiplication, or division to isolate. And if you're wondering, does it get worse? A little bit. You might have to, on occasion, use a square root or a cube root, but that's the worst it gets. So I'll just continue over here. So we're trying to solve for B. B's looking pretty good now. We've gotten to a better place because now you just have to get rid of D. So that D is multiplying by B. So the opposite of multiply is to divide. We'll divide both sides by D. Like that. And that gives us our final answer. Even though the other side looks a little bit intimidating to people, that is exactly the formula that you want to use. So the final answer is this expression right here on the right. Okay, I think it's a good time to take a break. Why don't we meet up again at 10 o'clock? I'll do some prep work on the slides here that I want to introduce some extra questions. So we'll resume class at 10 o'clock. In this case now, the MV squareds are going to cancel on the left side. So let's cancel those out. And that leaves you with something a lot simpler. Ultimately, we're trying to solve for H. Anything in this term here that's not an H needs to be divided away because all of these numbers are multiplying by the h. So what I can do here is divide both sides by 2, by m, and by g. Now you might say, John, you're dividing by 2, but earlier you multiplied by 2. I know that's a little bit weird, and it just points out that you don't actually have to do this first step in blue. But the reason I did it is because there's less fractions involved along the way. So let's divide both sides by 2mgh, 2 by 2mg. Because at this point, the question is done. We've successfully isolated h. See, the 2's cancel, the m's cancel, and the g's cancel. So we have exactly what we desire. I might squeeze 15 in here on the side and then do 16 below. 15 is not that long. We'll just kind of do the questions in that order. If this question 14 made you nervous, this probably will be one of the longer questions that you would see in this chapter. 15 definitely is a lot shorter, I'll tell you that. So in question 15, we want to isolate for r. Again, this step here is not, it's more cosmetic, but I'm going to write it backwards so that I can have the r on the left, just because it's my preference. You want to get r by itself. So the thing that you want to deal with here first is the pi. Pi, like any other variable or constant, can be divided on both sides. So divide by pi, as so. Those pi's cancel. So you end up with r squared equals 4 over pi. Can someone let the class know in the chat, how would you finish this question? How do you get rid of the square? What do I do next? What should we do next? What do you think would be a good idea to get rid of that squared? Yeah, that's right, Marco. Good job. So what you want to do is square root both sides. So there it is. There's the answer. It's a over pi with this, r over pi with the square root on it. So that's our first example today where we've actually had to take a square root. And once you've done roots as well, there really isn't much new to look at. So at this point, we'll just practice question 16, which is very similar to 15, except that instead of dividing both sides by pi, we're going to divide by pi h. But basically, it's the same question. It's the same question so much that what I could do is literally copy this whole thing here. Well, that's supposed to be an A. I'm so sorry. I wrote it as a 4. The 4 and the A look so similar on the screen for whatever reason to me. Okay. So I can apply a very similar situation here. I want to get rid of the pi and the h. So essentially, we're doing the exact same steps now. I can copy and paste this whole thing here. And right here, pi h. Like that. That's the answer. It looks so similar to the previous question. The presence of the h doesn't really change things too much. I went through these a little faster in case some people had tried this during the break. So Anyway, there you go. What are you going to see on an assignment or a test? Honestly, I don't think you're going to see anything too dangerous on your assignments or your test. Maybe one question on the test, just because it is our last test. Your next test is in 2 weeks, your final test, I should say. So you might see one harder one, because obviously it's the last test. I gotta go out with a bang, right? We gotta put a good one. James, it's exam week is weird because some people have their exams in week 14 or 15, depending on the course. So your final test is in 2 weeks from today. It's the last week of class. So it's in the last week of the semester. So that's December 15th. You're welcome. I will be putting information about your final test on Blackboard. Hopefully by Sunday. I'd like to have at least a draft of the test ready so that I can share information with you about that. But basically, your final test is just like your first and second test. It's worth the same as the other ones. It's not intended to be anything harder or easier. It's just another test. I might put one tough question at the end compared to the other ones, a little bit harder, and that's just because I want to just see. I want to give an opportunity to some of the stronger students to show what they got, so to speak, in terms of their skills. But anyway, that's all I really want to say about that. I don't want you to get too stressed out about it. You've already completed 75% of the course because with two assignments and the test, that's only 25% left. So once you're done this week's assignment, you're basically 80% of the way in terms of grades. All right. And next semester there is another math course, and I may be seeing some of you in that course depending on your schedule and depending on what happens in terms of things beyond our control in terms of the scheduler. But if I see you in the next one, it's going to be the same structure as this course. Okay, so let's keep on going here. I have a few questions left to cover with you. We have 22, 23, and then this one F, which comes from page 12. So let's go and do these questions together. You didn't have an option. Yeah, I know, Norris. I know some of you emailed me and said the same. So not sure how that's going to work out. But I will tell you this: the professors are very good in the program. You'll be just happy with them. Uh, if and also I'll be putting up all of my notes and videos and whatever on YouTube for the other course too. So even if I don't have you as my student next semester, you're more than welcome to visit my the videos there, and you can at least see some additional support that way, and maybe reminisce on a good fall experience. Okay, so we're gonna do a few more questions now. Take us over to question 22. Let's take a look at 22. These would be considered tougher questions, so if anybody here is getting a little bit worried, these are definitely a little bit tougher. So don't don't feel like you're alone on this one. I'm sure there's many other people in the audience that are like, oh yeah, these are getting gross. I'm just gonna space these out a bit better because I think it'd be wise to do that. Okay, so here's our next example. We've seen this equation earlier. It was the energy equation that I wrote down based on question 14. So I'm just going to copy question 14, like the actual text box. So here we're doing this. Sorry if I'm making you dizzy. We're solving for h here. So let's go through that together. So that was h for the previous one. Now we're solving for m. Okay, satisfied. Solve for m. Now, m appears multiple times in this equation, so we're going to have our work cut out for us. This will probably be a level of algebra that is hopefully familiar to you. It's factoring, a little bit of factoring. The first thing I want to do is get rid of the 2. Sorry, I don't like that 2 there. So I'm going to multiply by 2. Now that I've multiplied by 2, at least I've gotten rid of the fractions. Let's write the equation backwards. I just want to write it backwards so that I can have the m on the left. So in this situation, m appears multiple times. What you want to do is find a way so that m appears only once. And the way that you can do that is by what's called factoring. So we're going to factor out an m. Now this step here is going to be scary to a few people because you haven't done factoring probably in a while, or maybe when you did factoring, you weren't as strong at it as other topics in math. Let's talk about what I did there. Let's play this out in reverse. How would you deal with this m in terms of bringing it into the bracket? You would multiply the m by v squared and get mv squared, and you would multiply the m by 2gh to get 2mgh. So really, this step here about factoring is something that you can practice based on reversing the process. Like you can see here that if I wrote it backwards, I get back what I expanded. Now you're like, I get that, but maybe I'm a little bit worried about being able to reproduce that. So give me just a little bit of a few minutes of 30 seconds on this, and I'll share a link to a video that'll help you with this. I'm just searching it up on my web browser. You might hear some audio.
My name is Ariel, and I just started.
That's great. It was a commercial. Someone's talking about their advertising here. We don't really care about advertising now. So let's copy that link. There's a link to a video that will help you with this step. So if you're like, I want to learn this better, watch that video. It's about, I think, about 10 examples, and it'll help you understand how you do that type of question. Anyway, we should proceed now, because the good news is that m appears only once. And m is being multiplied by this long expression. So what we should do is divide both sides by that. So if we do that, we get the following. That looks scary. You're seeing a lot of symbols on my screen here, but think of it as a picture. See, this thing here, what if that thing was just the letter, what if this thing here was just the letter G? Then you would just divide by G. That's what I'm saying here, is that don't let it scare you that it's this entire bracket. Think of it like a picture. So you're going to divide both sides by that same image, so that these things are identical and can cross each other out. Because that's the answer to the question. Now that we've completed this question, I do strongly believe that you're in a position that you could answer all the exercises in the notes. Because we had exercises that started off with like addition, subtraction, multiplication, division, and then we did a couple questions that involved square roots and squares, and now we've done questions involving a little bit more in-depth algebra. If you take all these little examples individually and kind of blend them together, those are all the different skills that you need really to rearrange most formulas that you'll ever encounter in your life. Like, I'm not talking astrophysics here, okay? I'm just talking like formulas, algebraic formulas that involve the arithmetic that you've been familiar with all your life, including just BEDMAS and some square roots. So I'd like to do 2 more questions that are a bit more involved, like this one was. We'll take them nice and slow, and hopefully build your confidence in terms of doing things. And as you know, when I do make questions up for assignments and tests, I do try to pull questions from the notes. So I hope that you do see some similarity between what I ask you in terms of formulas for the assignment and the final test. So here's our next example. I'll retype this one because it might be difficult to read from this angle. So this is a over 1 plus ab. Okay? That's the formula. We're solving for a. I'll just put a in quotes. So there you go. So the first thing that you may notice here is that a appears multiple times, kind of similar to the previous example. So hopefully we can apply tricks and techniques that or patterns I should say, that we saw in previous questions. As with the other questions involving fractions, my first step, regardless of the variable that I'm trying to solve, when I see fractions, my first step is to clear the fractions. So I'm going to cross multiply here. So to cross multiply, that means I need a fraction on the left side. This is a fraction because h is equal to h over 1. That allows us to cross multiply here. So if we multiply on the left, if we multiply diagonally to cross multiply, we end up with the following. H times 1 plus AB is equal to 1 times A. Now, the stuff on the right is easy. That's just A. This thing here, we're going to distribute. We're going to do H times 1 and H times AB. So H times 1 is H, and H times AB is ABH. I put H at the end if you don't mind. Just put them alphabetically, I guess. We're trying to solve for A. So anything that has an A in it, I want to put it on one side. Any term with an A, I want to put it onto one side. You could move the A's to the left side or to the right side. It does not matter. Now you're not gonna. I'm gonna move all the A's to the right hand side. I know that's weird, but let's see why. Let's see why. So I'm gonna subtract ABH from both sides to get that ABH to the other side. I'll explain to you why I did that before I do it actually. I'm gonna move the A's to the right. That's the reason I'm doing it, okay? So if you're wondering, why did I move it the other way, which seems so counterintuitive, it's because I want to minimize the number of negative signs. If I went the other way, I'm going to have two negatives, and I don't like having all the negatives in the question. So hopefully that you can appreciate that. You see, this way, there's only one minus sign. If I did it the other way, there would be two minus signs, and it would actually mean more work later. So let's just cross those guys out. Now let's write this backwards. And we're in a position where we can actually finish the question now. This question definitely is on the tougher side, and you can see how the difficulty does escalate compared to where we started with today. So I'll finish the question over here on the far column. So what you want to do now is, I see two A's here, but I only want to have one A. So we're going to do the factoring step that we did earlier. We're going to factor out A. So if we take A out of the left, we have 1 minus BH. Again, if you want to practice this type of thing that I'm showing you here, I have a link to a video on the previous slide. The main idea is that you want to think of writing this as a multiplication of A times something, so that A only appears once this way, because then you can distribute that and you can always check it, but this way having the A appear only once allows us to solve for A. So if we divide both sides by 1 minus BH, That should help us finish the question. So we have the following. You don't need to put brackets on the bottom. The only reason I'm putting brackets there is so that I can copy and paste. So the final answer is going to be A equals H over 1 minus BH. I can understand that some of you are getting intimidated by seeing all of these variables and seeing a question this long. Not all questions are going to be this long. So don't get too worried about this specific question. As long as you can do most of the other questions, then you should be in a position to build up confidence. And then once you've built up your confidence, you'll be able to revisit these questions and hopefully proceed through them with a bit more success. These are not questions that people become experts at doing overnight. This is not a question that I would expect anybody to just walk into this class and be like, yeah, this is easy. There's certainly a few people here that will be able to do this question without too much support, but this is definitely a question that would require some additional effort and attention to solve. So that's why these last few questions that I'm doing here, they're not easy questions. So if you're getting scared here, it's not just you. There's a lot of people here that are going to be a little bit intimidated here. But we can't do all easy questions the whole class, because we gotta show you how you can build up your strength in doing these questions. I'll pause for 30 seconds, and then we'll do the last question here, this one here labeled F. Okay, so this will be our last question for today. I think that's enough for today. After that, I can show some students were talking about the software for writing math and formulas. I can show you that too. So in this question, we're trying to solve for P. I don't know about you, but that looks pretty messy. But I'm going to shock you a little bit and tell you that this question, in my opinion, in my strong opinion, is easier than the previous two questions. You're going to be like, but John, there's like roots and fractions here. Well, let's take a look here and see what's happening. First, I'm just going to type the question out so that it's easier for me to manipulate. So the first thing that we notice is that there's fractions. And there's also a square root that we have to kind of get rid of. As with most questions that I've shown you today, if not all of them, regardless of the variable that I was solving for, the first thing that I like to do personally is get rid of the fraction. I find that getting rid of the fraction, it really does make life a little bit easier. You don't have to, like, this question here, it actually benefits you to not get rid of the fraction. Like, this BC is not bothering us. The thing that's bothering us is the A. This A on the bottom is the issue. So let me not clear the fraction this time. Let's just get rid of the A. So we're going to multiply both sides by A. If we multiply both sides by A, like that, then these A's on the left will cancel. If you do it the other way by cross multiplying, it'll add one extra step. So that's why I'm doing it this way, because we can learn from our experience and build up more efficient answers. Now what's happening over here is we have B over C times A. I'll just organize that a little bit better like this. Your turn. How do we get rid of the square root? Because we're trying to solve for P. We're trying to solve for P. So how do you get rid of the square root? What's the opposite of a square root? That's right. Square is the square the opposite side. Beautiful. Thank you. So P minus Q is equal to this guy squared. Some of you are like, I don't really see that, and I'll put an extra step in there. But the step that I'm showing you is optional. So the optional step would be like this. You have this expression here, and you want to get rid of the square root. So whatever you do to one side, you do to the other. To get rid of a square root, I need to square this. But I can't just square one side. I have to square both sides. So that's the logic of how the square appears on the other side. It's not magic. You're not moving it over or anything like that. This squared here is neutralizing the square root. So we're in a position now where we're so close to the answer. You can see the answer in front of you, hopefully. I'll just finish it up in 2 lines over here. I'll just finish it right here. So we're solving for P. So just add Q to both sides. Or if you want, just say move Q to the other side. And that's the final answer. We barely picked up our calculators today. You might you might say, well, is that a good thing or a bad thing? I don't really know. Depends on what your thoughts are. I'll tell you, in undergrad, where I did my undergrad was a program called engineering science. And in that program, pretty much all the math courses were like, well, we could use numbers, but let's just use everything as variables because, you could put numbers in later yourself. And that was pretty much most of my courses in undergraduate university. But anyway, you don't have to suffer that much as I did for that kind of stuff, hopefully. And hopefully through the stuff that we've been doing today, these formulas are less scary to you. I don't know, what do we do, like about 20 questions, I guess, maybe 15 or 20 questions. I'd say that if you understood how to do at least half of them coming out of today's class, that's very good. And make it your goal to try to make sense of the ones that maybe were a little bit more difficult today. That'll be enough for today's lesson. I'm going to stop the recording and I'll stick around for questions. And if anybody has no more questions, then I'll show that software package that I was telling you about.